Hi class, I'm gonna cover section 1.4 today, basic notions of functions, part 1. During this lecture, I hope to cover these topics, definitions, definition of a function, functional notation, difference quotient, domain and range. Okay, these are a couple of examples for functions. Taxi cab fare is a function of the distance traveled. As distance traveled, taxi cab fare is increasing. Second one, height is a function of someone's age. Similar to the first example, uh, as somebody getting older, his height is increasing, but not continuously. At a certain age, after a certain age, height is a constant. Uh, let's look at the definition of a function. A function is a set of ordered pairs obtained by some rule so that to each first element in the ordered pair, there corresponds a unique second element in the ordered pair. Uh, Function is a set. It consists of x and y, or it is the relation between x and y. Means we can say it is input and output. Here is an example for a function and not function. F is a function, G is not a function. Let's see uh, how it works. Uh, F is 1, 3, 2, 5, 9, 11, 5, 8. Its x is not repeating, therefore it is a function. On the other hand, G is defined as 1, 3, 2, 5, 9, 11, 2, 8. There you see the x coordinate 2 is repeating. Therefore, G is not a function. Since x coordinate repeating, G is not a function. Okay, F is a function since x coordinate not repeating. Also, I want to tell you something else here. See, F is separate 4 point, discrete 4 points. Therefore, it is called a discrete function. We're going to see a continuous functions later on. Okay, function notation is this y equals fx. This means that y is the value associated with x, or y is a function of x. We're going to see an example, then you understand this better. This is called functional notation. This is the example for that. Let's take this one, fx equal to 2x plus 1. This is a continuous line. This is same as y equals 2x plus 1. Now, if you do this y equals 2x plus 1, it is continuous. Therefore, it is called a continuous function. It is not separate few points. It is a whole bunch of points next to each other. Right? So it is a continuous function. Continuous function. Okay. Now, if you want to find a function value with a given x value, all you have to do is substitute that given x value for x here and find fx. For instance, if you want to find f5, you're substituting 5 for x, you get 2 times 5 plus 1 is 11. Now, in case uh, you want to, uh, in case um, since this is going from negative infinity to positive infinity, means this function is defined for all x, right? Therefore, you cannot write uh, uh, in like we did with ordered pairs, right? When x equals 0, there is a y value. When x equals 1, there is a value 2, there is a value 2.5, there is a y corresponding y value. Therefore, it is infinite number of data points. Therefore, instead of write it like ordered pairs, we can draw the function like this. We know it is a straight line with positive slope, and it has y-intercept at 1. We learned this. We learned how to do the draw straight lines, right? So we means the main idea here is you cannot write the function as a set of ordered pairs, because it is infinite number of points. Uh, Therefore, instead of writing x and y ordered pairs, we can draw the graph of the given function. Okay, let's do this example 1. Given the function defined by the equation y equals fx equals x squared minus 3x plus 4, you don't have to write y equals fx equals this. You can eliminate this y and say fx equals x squared minus 3x plus 4. Now, we want to find these function values. Let's see how to do that. Part A. Okay, anyway, we have this equation fx. Let me write fx equal to x squared minus 3x plus 4. We want f0 equal to, when x is 0, this term is 0. Whatever with x, that term is 0. 3 times 0 plus 4. So this is equal to 4. f0 equal to 4. B f negative 2 negative 2 square minus 3 times negative 2 plus 4. Negative 2 square is positive 4. Negative 3 times negative 2 is positive 6 plus 4. This is 14. C f of 2x means wherever you see x, you substitute that with 2x. 2x whole thing square minus 3 times 2x plus 4. 2x square is 4x square minus 3 times 2 is 6x plus 4. That's the answer to f of 2x. Okay, the next topic is difference quotient. Um, uh, the difference quotient is this here. Just looking at this, you may wonder why we calculating this or why we especially interested about this. Because we need this in calculus within this semester, right? Before long, we're gonna use this. We need this in the study of calculus, and the difference quotient is defined by this fx plus h minus fx divided by h. Um, for for given functions, we're gonna find this difference quotient. For linear function, say fx equals mx plus b, which is a equation of a line, the difference quotient will be turn out to be precisely the slope of the line. In case of straight line, if you calculate this ratio, this is same as m equal to m for a straight line. Okay. Example 2. Compute the difference quotient for the function defined by the equation this. Okay, let's do this. Solution. Fx is this. Let's find fx plus h. X plus h, how we find that? Substitute x with x plus h. X plus h square minus 3 times x plus h plus 4. What we get here? We get x square plus 2hx plus h square minus 3x minus 3h plus 4. Okay, we are calculating this ratio, difference quotient ratio, fx plus h. Now we're gonna calculate fx plus h minus fx. Fx plus h is what we calculated here. X square plus 2hx plus h square minus 3x minus 3h plus 4 minus fx. Fx is this given equation x square minus 3x plus 4. X square minus 3x plus 4. Here, positive x square. This cancels with negative x square. Negative 3x cancels with this negative times negative, positive 3x plus 4 cancels with negative times positive, negative 4. Right? So what we get, 3hx plus h square minus 3h. Right? Now, here you see h is common. If you take h out as a common factor, we get 3x plus h minus 3. Now we can calculate the difference quotient. This is fx plus h minus fx. If you divide both sides by h, we get the difference quotient. We have h times 3x plus h minus 3 divided by h. And this h to h cancels out, we get 3x plus h minus 3. So this is the final answer for the difference quotient. Okay. Next is rationalize. Rationalize means simply get rid of the numerator. If the question asks you to rationalize the numerator, you get rid of the radicals in the numerator. If the question asks you to rationalize the denominator, you get rid of the radicals in the denominator. Okay, let's do this example. Rationalize the numerator. See, it's asking you to rationalize the numerator. That means we have to get rid of this radical part. See this radical part. We want to get rid of this radical part in the numerator. Right? So what we do, this procedure, it is useful to remember this solution. We have this given expression, square root of 9 plus h minus 3 divided by h. To get rid of this radical from the numerator, what we do, we multiply this by the reciprocal of numerator. Reciprocal means you simply change the sign in the middle. This is plus 3, you change this, you change this minus to plus. Plus 3, we have to multiply both numerator and denominator. Because if you multiply just one, means if you just multiply the numerator, it changes the fraction. In order not to change the fraction, we have to multiply both numerator and denominator. That's 3. Look at the top. It is like a minus b times a plus b. What we get if we multiply a minus b times a plus b? This is equal to a square minus b square. Look, first term square minus the second term square. We can do the same thing here. First term square, 9 square root 9 plus h square is just 9 plus h without square root. Minus second term square is 3 square, which is 9. Divided by h times square root 9 plus h plus 3 is positive 9 to negative 9 cancels out, and we get h over h square root 9 plus h plus 3. Then this h to h cancels out. We get 1 over square root of 9 plus h plus 3. Okay. That's example 3. Example 4. Determine the difference quotient for fx equals square root of 2x plus 1. The result should not contain any radicals in the numerator. After the numerator, after the rationalization process is completed, determine the value of the expression for h equal to 0. Okay, we know how to calculate the difference quotient. Let's calculate that. After that, let's substitute h equal to 0. Okay, let's find out first the difference quotient. Fx is given square root of 2x plus 1. If x plus h is what? Square root 2x plus h. We substitute x plus h for x plus 1. Then let's calculate fx plus h minus fx. This one we can write this as we can distribute this and write it as square root 2x plus 2h plus 1. Let's write the difference quotient, which is f of plus h minus f of x divided by h. fx plus h is this line, square root 2x plus 2h plus 1, that's fx plus h. If x is minus fx minus square root 2x plus 1 divided by h. Right? This is the difference quotient, but we want to rationalize this. See, the question asking us to, after the rationalization process is completed, then determine the value of the expression for h equals 0. Now, to rationalize what we do, we multiply this with the reciprocal of the numerator. We multiply this with square root of 2x plus 2h plus 1. Change this minus to plus square root 2x plus 1. Divide by the same thing. Write the same thing on the denominator. Two x plus 2h plus 1 plus square root 2x plus 1. Okay. Now again on top we have a minus b times a plus b, which is a square minus b square. A square, we can write that the square of the square root, we can just write the inside of the square root, which is 2x plus 2h plus 1 minus b square is 2x plus 1 square root square. And we can write that as 2x plus 1. This divided by h. Positive 2x, negative 2x cancels out. The positive 1, negative 1 cancels out. We get 2h over h. Then h to h cancels out and we get 2. Then it's asking us to determine the value of the expression as h approaches to h equal to 0. When we substitute h 0, since this expression is independent of 2, it stays as 2. It stays as 2. It's like when h equal to 0, f x plus h minus fx divided by h equal to when h equal to 0, number 2. When h equal to 0, number 2 is, it stays the same, 2. Wait, here we forget this second part, 2x. This one, square root 2x plus 2h plus 1 square root of this plus square root 2x plus 1. Okay, let me erase this part here and do that over. I'm sorry, I forget about this part. I have to consider that. Okay. That's the mistake I did. I multiplied the numerator, but I forgot this part of the denominator. From here we get h. From this part we get square root 2x plus 2h plus 1 plus square root 2x plus 1. Right. Now you write the same thing here. Then simplify this. These things cancel out. We get 2h here. H times square root 2x plus 2h plus 1 plus square root 2x plus 1. This h cancels out. Now we get 2 over square root 2x plus 2h plus 1 plus square root 2x plus 1 Okay, when h equal to, now this is the difference quotient. We cannot simplify this any further. Now we can set h to 0 when h equal to 0, fx plus h minus fx divided by h equal to, now wherever you see h, substitute 0. 2 divided by square root 2x plus 0, 2 times 0 is 0, plus 1 plus square root 2 times x plus 1. This is equal to 2 divided by, here we get square root of 2x plus 1. Here we get square root of 2x plus 1. When we add them together, it is 2 times square root of 2x plus 1. Then this 2 cancels out. We get 1 over square root 2x plus 1. Right? So this is the final answer. When x is equal to 0, the difference quotient is 1 over square root of 2x plus 1. Okay, now let's look at domain and range. Domain is the set of x coordinates, all first elements in the ordered pairs, where the function is defined. The range, on the other hand, is the set of y coordinates, all the second elements in the ordered pairs, where the function is defined. Where the function is defined, see, that is very important. Where the function is defined, we have to find where the function is defined. So wherever function is defined, domain is x value, range is y values. Right? Keeping that in mind, let's do this example. Determine the domain and range of the function defined by the equation y equals fx equals negative 2x plus 5 between 1 and 4. Okay, the given function is fx equal to negative 2x plus 5. Now we want to find the domain and the range. We know any polynomial. Now this is a polynomial, negative 2x plus 5. Is continuous from negative infinity to positive infinity. Right? But they give us uh, where it is allowed, the x values where it is allowed. It is between 1 and 4. On the other hand, this thing question giving us is the domain. The question gives us 1 less than or equal to x less than or equal to 4. Okay, we can write domain is equal to between 1 and 4. We have equal sign 1 comma 4 bracket. Okay. Okay. I did something, pressed something by mistake. All right. So our domain should be between 1 and 4, including those values. Because we have equal sign, we have to include 1 and 4 as well. Now, how do we find the range? Since this is a continuous function, we know that for sure because it's an equation of line. In fact, this is a line with negative slope. It is decreasing. Let's substitute these end values and find the function values. Means let's find f of 1 because we want to find the smaller value from those two. Because when we write domain or range, we write always the smallest value first, the highest value last. If 1 is equal to negative 2 times 1 plus 5, this is 3. On the other hand, if 4 is 1, if when we substitute 4 there, it is negative 2 times 4 plus 5. Negative 2 times 4 is negative 8 plus 5 is negative 3. Therefore, we can say the range is smaller y value. What's the smaller y value? Negative 3. The higher y value is positive 3. Therefore, we can say its range is negative 3 to positive 3. I'm going to explain that using the graph too. Now, from what we learned about the equation of straight lines, we can say this is x and y. First point here is what is the x coordinate? Let me see. X coordinate is 1 when x coordinate is 1. It is that correspond to 3. 1 comma 3. This point is included because it is given 1 less than or equal to x less than or equal to 4. So this point is included. This point is this is like 4 comma negative 3. See, domain is x value. This x value is 1 and this is 4. So it is 1 to 4. This, the smallest y value, on the other hand, this is negative 3 and this y value is positive 3. So therefore, the range is -3 to 3. All right. Okay, that's it for number 5. Number 6, determine the domain and range of the function defined by the equation fx equals 2x square root of 2x minus 3. Now, the function is defined as square root of 2x minus 3. When we find in domain, the best thing that you should think about is the restriction. See if it has any, if the given function has any restriction. I mean, in this case, the square root is the restriction. Why? We cannot have negative number inside the square root. Right? We can have any positive number or zero. We cannot have any negative number. Therefore, we can start from there. That is the restriction. We can say the contents of the square root, which is 2x minus 3, whatever inside the square root should be greater than or equal to 0. This is how we say positive or equal to 0. 0 is okay because square root of 0 is defined. Square root of 0 is 0. Solve this inequality, we get x greater than or equal to 3 over 2. Right? X greater than or equal to 3 over 2. Now if you do this on the number line, we have 3 over 2, since we have shade the circle greater than always to the right. This means from here all the way to positive infinity. Therefore, we can write domain quite easily, including this point 3 over 2 to infinity. Infinity you never include because it is not a definite number. You use parentheses with infinity always. Now, range. How we find the range? Now, this function, when x equal to, we found x greater than or equal to 3 over 2. How we found that? When we set 2x minus 3 greater than or equal to 0. If we set 2x minus 3 equal to 0, we get x equal to 3 over 2. Right? That means that is the smallest y value it can get. Whenever we substitute anything bigger than this, 3 over 2, when x is 3 over 2, this is 0. Square root of 0 is 0. If you substitute anything greater than 3 over 2, 3 over 2 is like what? 1.5. If you substitute 2, 2 times 2 is 4, 4 minus 3 is 1, greater than 0. If you substitute anything, 2 times 6, say x is 6, 2 times 6 is 12, 12 minus 3 is 9, right? Uh, Square root of 9 is 3, greater than 0. So as x increasing, this fx value is increasing unboundedly. Therefore, the range should be the smallest value of the range is 0. That point is included Modus value is 0. I'm sorry. How I change this? Modus value is 0. After that, function increase unboundedly. Therefore, upper value is infinity. The range is like this. I explain you using the graph 2. You plot this graph. You may use the calculator or you may use few points and do the graph. When x equal to 3/2, y value is 0. This is 3/2. And after that, as x value increases, y increases. We know the square shape of the square root. It's like this. Right? So this domain and range we found well agrees with this graph. Okay. Example 7. Determine the domain of the function defined by the equation f(x) equals x over x squared minus 7x plus 12. Now, you see in this question, they do not ask us to find the range, it's only the domain. We're gonna find range for this type of functions in next lesson or lesson after. For the time being, let's find the domain. As I said, when we find domain is the restriction, right? Where this function restricted? Let's see. Fx is what? It is x divided by x squared minus 7x plus 12. The restriction is the denominator. Means under what conditions this function is undefined. If this denominator is equal to 0, this function is undefined. Therefore, we can say the denominator of this x squared minus 7x plus 12 should not equal to 0. Understand? It is not greater than 0, it is not less than 0. Whatever it is, the function is defined. When the denominator is positive or negative, it does not matter. You get a positive divided by negative, it's a negative. Negative divided by positive is a negative, right? You know those rules. The only where the function is undefined is if the denominator is 0. If this denominator I'm showing, if this denominator is 0, it is fx is undefined. Therefore, we say the denominator should not equal to 0. Now let's find for what x values this denominator is 0. To find that, let's factor this. Factors of 12 that gives us 7 is 4 times 3. This is x minus 4 times x minus 3 not equal to 0. This gives us x minus 4 not equal to 0, or x minus 3 not equal to 0. Here we get x not equal to 4 or x not equal to 3. If you put this on a number line, 3 is the smaller number and 4 is the big number. X cannot get these two values. That means x can be anything this direction, this direction, this direction, or this direction. Do not shade the circles. X can be any number this way, any number this way, any number this way means in between any number, and after that towards infinity. Therefore, we can write the domain of this as negative infinity to 3 union 3 to 4 union 4 to infinity. Okay, that's the domain of this function. All right, I think that's all I have for today. I'll get to the part 2. All right, thank you for participating.